In section 6.2, we're going to factor trinomials. We're going to do what's called the factor of these in the nice case. So a trinomial means we're going to have three terms. Factoring in the nice case means we're down here. What's nice about this is that when you're working with this trinomial, there's nothing in front of your squared term. It's understood to be a 1. In the not so nice case, that's going to change. So right now, we're in section 6.2 with the nice case. 6.2. Let's understand what we're going to be tasked to do. You're going to start out with a trinomial like this. We're going to have to work backwards. We're going to have to factor this, figure out, well, what two things did you multiply together to get x squared plus 8x plus 15? In this case, we can see it, but let's use this to try and figure out what you're going to have to do in general to factor these things. There's a couple clues. Let's look at the 15. Where did we get the 15? 5 times 3. Where'd you get the 8? 5 plus 3. Good. So when you're factoring these things, start out by looking at that last number. You want to find two numbers that multiply to that last number and add to the middle number. That's going to be the way we work on these things. It's summarized in its own way down here. Let's see if we can't put that into practice. We'll start with problem number 18. X squared plus 7x plus 10. So we're going to factor that into two binomials. Now the first term is always going to be dictated by this, of an x here and an x here. So the x times the x will give me the x squared. Since all of these terms are positive, my binomials have to have positive signs here as well. Can't have a negative in here and end up with positive products in any way like this. Last but not least, I need two numbers that multiply to 10 and add to 7. Yeah, 5 and 2. 5 and 2. You could also write this as x plus 2 times x plus 5. I really have no preference for one versus the other. Both of them are correct. You don't have to have it in any particular order there at the end. That's it. You're done. Yes, sir. A lot of times, yeah. Now, there are a lot of little nuances here, though. So we are going to do a lot more in terms of practicing. But, yeah, a lot of times they are going to work out pretty nice. Now, this one is pretty similar to the one up above, but there's one important difference here. Can anyone see what that big difference is other than the variable? There's a negative in front of the 7. That's okay. I should still start out with an n and an n, because an n times an n is n squared. Okay. I still need two numbers that multiply to 10, but this time they're going to add up to negative 7. So how can I change this? All right. Negative 5 and negative 2. They're both negative. Now this is one of a lot of details I'll probably throw you away. But if this is positive right here, then this sign is going to match this sign, always. So that sign. So when the last term is positive, these two signs match that sign. These two signs match that sign, always. So it's kind of a nice way to parse through things and figure out what's going to go on with your signs. Let's take a look at problem number 24. U squared plus u minus 42. Like a lot of these, let's start out by filling in the first term in each binomial. Nicole, what would that be? What should I put here and here? Good, u and u. Let's think carefully about the signs here. I have a negative 42. So what has to be true about the signs here and here? Yeah, one positive and one negative. That's the only way you're going to get a negative product. If they were both negative or both positive, you'd end up with a positive product. So these have to be opposite each other. Now I need two numbers that multiply to 42 and add to 1. That 1 is not necessarily really written for you, but it's understood to be here. Two numbers that might jump out at you are 6 and 7. But which one's positive? Which one's negative? 7's positive, 6 negative. Okay. Let me give you two different choices here. I've got one vote on this, so that's going to be U plus 6, U minus 7, pardon me, or U plus 7 and U minus 6. How many people think the first one? Couple. How many people think the second one? Yay. Second one wins. And not just because this is a democracy, because you're right. The sign here, the sign of the larger number is going to match this sign here. So if this is positive, the larger of these two numbers is also going to be positive. The sign of the larger number matches this sign. So let me see if I can't color coordinate. 7 was a larger number. 7 has to be the positive number. Okay? And then the other one is negative. Let's try problem number 30. X squared minus 3x minus 40. So again, we're looking for two numbers. One of them is going to be positive and one of them is going to be negative. So x plus something, x minus something. I know that because the sign of that last term is negative. Cool. What two numbers do you think you're going to end up using? 8 and 5. Good. Now, according to that idea that I just gave you, which one of these has to be the negative one? 8. So x plus 5, x minus 8. Okay. How do you check it if you're looking at that going, you know, I didn't do so good on the last test, I better check it. How would I check it? Yeah, FOIL it. So we can check it. If I check it, it'd be x squared minus 8x plus 5x minus 40. So, cool. It checks. This matches what we started with. How are we looking at number 30? Let's do a little bonus problem for problem number 30. If I did x squared plus 3x minus 40, would that change anything? Yeah, it's going to change the signs. Dwayne, what would that look like if I factored this one? Perfect. Exactly. So it's going to switch the signs, right? The larger of these has to have this sign. So again, it'd be positive 8 and then a negative 5. Nice. Thank you, sir. Let's look at problem number 40. A squared plus 6ab plus 5b squared. Let me rewrite that 6ab so that it looks actually like a 6. So try that again. A little Photoshop there. 6ab. Now, to make this one a little bit easier, I'm going to consider kind of a parallel problem for just a minute. A squared plus 6ab, let's just do plus 6a plus b squared. Nah. Plus 5. Sorry. Getting a little bit messed up here. A squared plus 6a plus 5. So I'm not going to worry about the b's for the moment. I think this one should factor pretty easily. Liam, what should I start out with? A and an A. What signs have to go here? Both have to be positive. Everything here is positive, so 2 positives. Good job. And now, there's not too much wiggle room here, right? There's only 2 numbers that multiply to 5. What are they? Yeah, 5 and 1. 2 numbers that multiply to 5, and they also add to 6. So, we're good there. But how does that change things up, or what are we going to have to do or modify for this one? This was the original problem. How am I going to change things up there? Well, I know I'm going to need an A and an A. Have the signs changed at all? Plus and a plus. The numbers here are going to have to be the same, so a 5 and a 1. But I haven't accounted for the B yet. How can I account for the B? What do I have to do so that when I multiply this all together, I get these B's in here? Exactly. I'll put a B here and a B here. So the only difference is that I'm adding that extra variable at the end of this, right? So I've got 5b and a 1b as opposed to a 5 and a 1. So you're just adding that extra variable at the end. If you checked it by foiling, if you're wondering, so well, wait a minute, where did my AB go? If you check it, you would get a squared plus AB plus 5BA, but I'll write that in alphabetical order, 5AB plus 5B squared. 1 plus 5 would give me the 6, so it checks. Let me give you another one like that to practice before I move to that other one. Is there any other thoughts on problem number 40 here? Sometimes you'll see me on exams put 2 problems like this side by side. And I'm hoping that if you get this one, then you'll surely get this one. You know, let me just give you, let me just make one up for myself, or for you, from myself. So suppose we had, say, x squared minus 2xy minus 24, y squared. Let's see if we can't factor that. Mariana, what should I start out with? What goes up front here? X and an X. How about the signs involved? What 2 signs should I use? Good, a negative and positive. This last term is negative. The only way you're going to get a negative is to multiply a negative times a positive. Or you can do positive times a negative. Good. Let's think about the numbers involved. Shane, I need 2 numbers that multiply to negative 24 and add to 2. So what 2 numbers are jumping out for you? Don't worry about the signs yet. Just are there 2 numbers that are kind of close to each other that multiply to 24? So let's think here. They're going to multiply. Let's start with the 24. So there's 1 and 24. 2 goes in there 12 times. 3 goes in there 8 times. 4 goes in there 6 times. Now one of these has to be negative. In fact, the larger of these has to be negative. So let me squeeze in a little negative sign here. and add them all up. That adds to negative 23. That adds to negative 10. And of course, it's the last one down here that adds to negative 2. So it's x plus 4 and then a x minus 6. There's still something else that I need here, though. LeBaron? Yeah, need to add the y's. So a y here and a y here. Thank you, sir. But don't get intimidated by these problems. It's just a little bit extra. You just got to add that extra little variable at the end there. To help him figure out the two numbers that he needed. Okay. If you don't need to do the table, if you can look at this and just come up with 6 and 4 right away, that's fine. So if you know that, gee, 4 and 6 are the two numbers that I want, and you look at that and go, okay, the sign of the larger one has to be negative right there, hey, that's fine. But it's good to see it done out methodically. We'll do that again when we do one in problem or section 6.3. Okay. Anything else on that example? From time to time, I'll write things in your notes like this. Factor out the GCF. In my mind, this is a signal to you that says, expect one like this. Be ready for this. This is important enough that you want to make sure you keep track of it. We'll start with problem number 48. 3y squared minus 21y plus 18. Now, unless you factored out the GCF to begin with, you're going to see in section 6.3 that this problem can be really, really challenging. We don't want it challenging. We want an easier problem. This is a kinder, gentler math class, right? So how can we make this a gentler problem? Factor out the 3. Thank you. So if I factor out the 3, what gets left behind? Y squared minus 7y plus 6. Now, can I just ignore the 3, just toss it out altogether? No. You have to keep the 3 around, but I can factor what's in the middle here. Now, I keep the brackets here just to show what I'm doing. But this y squared minus 7y plus 6. Let's see. Madison, up front. What should I start out with in these binomials to factor this? I'm not worried about the 3. If I factor this, how can I begin? All right, both y's. And what about the signs? What can you tell me about the signs? This one's positive, this one's negative. What's that say about both of these signs? Yeah, 2 negatives. Good. Last but not least, 2 numbers that multiply to 6 and add to 7. 1 and 6. Yay. That's it. I'm done with that one. Nice. But I guarantee you, especially after you see your work in section 6.3, it's a lot simpler to factor out the GCF here than it would be to do what we do in section 6.3. Your turn for 1. Problem number 50. (4b squared plus 12b minus 16). So I'm going to factor out the 4 as a GCF. Really, that means each of these terms needs to be divided by 4. Let me show you that. There's a couple of people who are struggling with the factorization. So let me show you the factorization, or a different reason for it. I've got a 4 times a b squared here, but 12 can be thought of as 4 times 3. And 16 is 4 times 4. So if I recognize that 4 is a GCF, then here's my common factor. That's the 4. And then here's what's left. A b squared, a 3b, and then a minus 4. So if you factor out that GCF of 4, you're going to leave behind b squared plus 3b minus 4. So all those terms are here. And then the GCF out in front. Personally, what I do is, in my head, I take each of these and I divide by 4. So the 4 will cancel that out. 12 divided by 4 is 3. 16 divided by 4 is 4. And of course the negative comes with it. Let's finish factoring this one. It's going to be 4. And then I'll start out with a b and a b. If this is a minus sign, what does it tell me about these two here? Yeah, one's positive and one's negative. So that I get a negative product. And then plus 4 and minus 1. Two numbers that multiply to negative 4 and add to positive 3. So 4 and 1. Notice the larger one gets that sign. Two more like that. Yeah, please. That's fine. Remember, multiplication is commutative. So, for instance, if I have 7 times 8, that's the same thing as 8 times 7. So the order in which you multiply doesn't make a difference. And that's true here, too, with binomials. The only thing that would be different is if you had the signs mixed up. If you had plus 1 and minus 4, that's where you'd run into problems. But if it's just writing them in a different order, nothing wrong with that at all. Both of these are correct. I wouldn't have issue with either one of these on an exam. Okay? Let's back up a step. Still kind of working with the same general idea, and that is factor out the GCF, although it's going to change a little bit for us. So in problem 32, we've got minus x squared plus 9x minus 20. Is there a GCF here? Kind of, sort of, maybe, possibly. Other vague terms that I can throw in there as well. But there is something I can factor out of all these. A negative 1. Now, we worked on this last week. What's going to happen when I factor out a negative from all these terms? Switch signs. Thank you, James. So switch signs, x squared minus 9x plus 20. Now that we got rid of that negative out in front here, I'll leave it there, but I can factor this. So really what's happening is I'm factoring what's inside here. You don't have to write the brackets. You do have to keep that negative out in front. X and an X. What can you tell me about the signs here? Both negative, right? We're ignoring that negative out in front. If this is positive, both of these signs have to match. They're either both positive or both negative. They can't be one of each. One of each would make this number negative. What are those two numbers? 4 and 5. Or you could write it as minus x minus 4 times x minus 5. You don't need those brackets there. I'll let you do one similar to that. Problem number 34. Minus a squared minus 15a plus 34. Carry. If I factor out a negative here, what would that look like? So a squared. And just like the last one, it's going to change all these signs, right? That went from negative to positive, positive to negative, negative to positive. So a squared good. Plus 15a and minus 34. We're going to factor what's on the inside now. So just worrying about this part here. Madison, can you help me out with that? A and A. A plus and a minus. Good, because that's minus, so these have to have opposite signs. Two numbers that multiply to 34 and add to positive 15. 17 and 2. All right. How are we looking on factor out the GCF? That part okay? It's not a step that you want to miss. It can make your life a lot easier by factoring out that GCF. The last little bit here that I want to cover, and we'll do 3 quick problems for this, is to reorder. By that, I don't mean to go back and get another Whopper with cheese. I mean, you know, change the order of the terms here. Like problem number 56, y squared plus 100 plus 25y. Something about this might look a little strange to you. It depends on how well conditioned you are from looking at lots of problems. But is there anything that looks odd or different? Here, the y is not the middle term. Generally speaking, we write things in descending order. So it'd be y squared plus 25y plus 100. So we've got a y to the first power, y to the second power, y to the first power, and then really y to the 0 power. Of course, anything to the 0 power is just 1. So you can ignore that altogether. That looks a little bit better. We can factor this. Ying, how should I start out? A y and a y. What about the signs? Both positive. Everything here is positive. Those two have to both be positive. Two numbers that multiply to 100 and added to 25. 20 and 5. What if Rochelle wrote this as y plus 5 times y plus 20? Should I mark it wrong? No? You guys are too nice. No, you're right. I don't have to mark that wrong. The order there doesn't matter. They're both positive. You should be in good shape. Problem 58. You try this one. X squared minus 13 minus 12x. If you get that one, you can try the grand prize, problem number 64. V squared plus 9v plus 15. But I'll warn you up front that that last one is different than what we've done up till now. Okay, so first things first, should probably reorder this. X squared, then what? Minus 12x minus 13. Good. So I need two numbers that multiply to negative 13 and add to negative 12. I'll start out with an x and an x. Let's throw in the signs too. Austin, what signs should I use here? Good, a plus and a minus. The last term is negative, so these have to have opposite signs. What would those two numbers be? Two numbers that multiply to 13, excuse me, negative 13 and add to negative 12? Yeah, there's not too many numbers that multiply to 13, correct? Just 1 and 13. And the larger one has to have what sign? So the larger one has to have that negative sign. So a minus 13 and a plus 1. Great. Let's look at the last one. V squared plus 9v plus 15. You look at that and you start kicking things around. You might, you're not getting very far. So let's make a table. We want to find two things that multiply to positive 15 and add to what? Add to 9. Now let's start with the numbers that multiply to 15. What are two numbers that multiply to 15? 3 and 5. Good. So 3 and 5. 3 and 5 add up to 8. Are there any other two numbers that multiply to 15? 1 and 15, and those add up to 16. Do any of those add up to what I need them to? So this is prime. Like I said, that last one I knew was a little bit tricky. You hadn't seen a prime one yet. Any thoughts on these last three? This last page here? Okay. For homework, try problems 15 through 93. Boy, that's an awful lot. Let me see if I can't pare that down a little bit. Let's do for problems 67 through 93. Most classes are good at figuring this out. EOO. Every other odd. Yeah. Do every other odd. There you go.